Welcome back for the next video in our solids series. So I'm going to go to my solids tab, and we are up to, I believe, a pyramid. So let me go ahead. Yes, this may be the last video of our solid series. But we're looking here at the volume of a pyramid. So take a look with me at this shape that we have. And I'm going to do a little bit of coloring so that you can see when I talk about the base of the pyramid. The base is what the pyramid is resting on. It's its foundation. And you may have seen the pyramids of Egypt, where the pharaohs were buried in these tombs that were shaped like this in their huge structures. It's amazing how they were able to build those structures without the technology we have today. But this is called the base of the pyramid. And then the other thing that I want you to notice is the height. And remember, we always measure height straight up. We're not interested in the slopes, the slants. We want the height of the pyramid from the ground up. So let me give you some numbers just to make up. I'm going to say that the height is 7 yards. This is not to scale, obviously. I'm just making up. And this is 4 yards. And this is a square, so this would also be 4 yards. So these are the only dimensions that you really need to do the volume. Now, if you wanted to do the surface area, you would need to know the slant on these, the sides. I do need to tell you that the sides, there are 4 of them. So if we were going to parse this shape, and we're not, it would be a difficult process, but you would have 4 triangular sides and 1 square bottom. So that's sort of the anatomy of a pyramid, a right pyramid. And before I show you how to do the volume, I want to show you a real-world example of this. I found a picture in Memphis, Tennessee. If you visit West Tennessee and you go to see the river, if you go to Beale Street, you'll see the pyramid. It's a Bass Pro Shop store. But in the top of this pyramid is a restaurant. You can go up there and eat dinner and look at the Mississippi River. I was there about this same time of day. This view is very familiar to me. And one of the things about this place that is so unique, it has one of the I believe it's the world's tallest, maybe the country's tallest freestanding elevator. So if you go in that Bass Pro pyramid, the yellow line here is an elevator that you can get on and ride to the top of the pyramid. Personally, I hated that. I do not like heights, and I definitely don't like elevators that are just stuck up in the middle of a building. But if you like that sort of thing, this is a really good trip. And you don't have to eat at the restaurant. If you don't want to, you can just ride the elevator and come back down. But if you like to dine in those kinds of places, I would highly recommend this trip. It's a good trip. Okay, let's calculate the volume of this pyramid. If you want to know what one of these looks like on the inside, you can go to Memphis and see it. The formula for volume of a pyramid is V equals 1/3, a big capital B, and an H. And I know that you've seen B in problems before, but it was the lowercase b. So here's what this formula is saying to me. Let me not write it in the middle of my paper. It's saying if you want to know the volume of this shape, here's what you need to do. You need to take 1/3 times the area of the base, and that's why it is uppercase, because there has been math done to get the uppercase, times the height. Okay, so that's what this formula is saying. And let me show you how it actually works. V equals 1/3 BH. So volume is 1/3 times the base area. And that's 4 times 4, length times width. And the height we made up to be 7. So here is the math. You can type it in your calculator just like it is. I like to simplify because I'm used to doing this without a calculator, and this was critical if I didn't have a calculator. But once I get it to this point, I definitely can do it on the calculator. You're going to say 1/3 times 16 times 7. And your Casio will give you a fraction answer. That's fine. And that's cubic yards. So it would take 37 1/3 of those little cubes to fill up this pyramid. I am not going to do surface area of a pyramid. It is a very tough formula, and I really don't think you need it. If you have good algebra skills, if they do give you the formula, you will be able to do it. But not everyone has had algebra, and I really don't want to overdo this. So, okay, let's do 2 more shapes, and we'll be done with solids. Here is the volume of a cone, and this says volume and surface area. I don't want to do surface area. I just want to do volume of a cone. And this is like an ice cream cone or a party hat. And because there is a circular bottom, you do have to worry about pi. Let me color the bottom for you. It's always a good idea to look at the base of something. And in this case, that base is a circle. So we are going to have to do radius, and we need to remember that height is measured straight top to bottom. So let's make up some numbers for this cone. I'm just going to use the ones in this book. I have borrowed to, the height is 8 centimeters. And the radius is, the radius is going to be 6 centimeters. So radius is 6 centimeters. And the example in this very good book is that this is a paper cup, a snow cone cup. And they want to know the volume of the cup. So the formula, I thought I wrote it. Oh, I did. Right there it is. I knew I saw it. Is volume equals 1/3 pi, because there's a circle, r squared h. And we can do this. It's not the easiest one in the world, but just take your time. The 1/3 is a number, so you don't put anything there. You know what pi is. You know what r is. Look at the graph or the picture. It's 6. And you know what height is. It's going to be 8. So the first step is to fill in all of your numbers. And then you want to deal with your exponent. Remember, that's 6 times 6, not 6 times 2. And then you need to put in the stuff you haven't used yet. So the 1/3, the pi, and the height we haven't yet used. And then once you get to this point, your calculator is going to do the rest for you. You can even just type in the fraction using your fraction key, and you will come up with 301.44. And let me do that just one more time, because again, my calculator does not have a fraction key. I left that one at my desk, so I'm having, yes. And this is cubic centimeters. So party hats, ice cream cones, snow cones, good stuff in cones. One more and we will be finished with our solids. And again, I'm not going to do surface area. So this is the volume of a sphere. And one thing I want to tell you here is how to pronounce this word. It is not spear. Okay, let me use a word. A spear is something you throw in a sporting event. It is not spear. It's pronounced sphere. And it's a little tough to say. You have a PH there that sounds like an F. So a sphere is basically a ball. It's a baseball, a basketball, and we're looking at how much air, maybe, that we could fit into this particular shape. The sun sphere in Knoxville is another good example of a real life structure. I don't have a picture of that one, but it would be a good one to look at. So let's say that the radius on this thing, and really that's the only dimension that we have to go on. The radius, I'm just going to make it up. I used to know the radius of a basketball, and I don't anymore. But let's use 5 inches as the radius for this thing. This may be a volleyball, soccer ball, I'm not sure. It may even be a basketball. I'm not sure what the radius is anymore. So the formula is 4/3 pi r, be careful, because this time it's to the 3rd power. So we have a different formula because this shape is not the normal shape. So the fraction is improper, that's okay. A lot of people want to turn that over and make it 3/4, but you can't do that because that's not in the recipe. Pi never changes, my good friend pi. And then the radius in this particular picture is 5. So plug in your numbers, and then let's do the exponent. Be careful here, it's not 5 to the 2nd power, it's 5 to the 3rd power. So do that on your calculator. 5 times 5 times 5 is 125. And then bring down your other pieces of this puzzle. I'm sorry if you're picking up background noise. It's very loud in here today. And then you just put this in your calculator, just like you have put any fraction in. It can be a top-heavy fraction, an improper. So you're going to type 4 ABC, 3.14 times 125. And I got this number. I need to check my work because my calculator doesn't do fractions. So 3.14 times 125 times 4/3. Yes. So this is 523 1/3 cubic inches as the volume of this sphere. Okay, we have completed yet another module. We are almost through this whole course. And just to flip through on the solids, we started with prisms, and then we moved to cylinders, and then we moved to pyramid, cones, and spheres. So the next module will deal with composites. This is my favorite one. The composites module I absolutely love. And the word problems. So I like all of this. But if you have a good understanding of your formulas, I encourage you to take the exam that is in this course outline. You can write down your formulas and use those, or I may give them to you in the exam. I haven't written it yet, but you don't have to memorize formulas. So don't worry about trying how I'm going to memorize all this stuff. You won't have to. You're going to have a formula sheet on the test for the high set. Now, I don't know about college entrance and other things, but you can use your formula sheet on my exams. I don't want you to worry about memorizing. So I'll see you in the next module, and we'll look at some really cool shapes called composites. Have a great day.